The development of COVID-19 vaccines was the fastest in our history. However, mutations are quickly popping up, reducing efficacy, and by the time we identify these mutations, more appear. Shortening the timeline from identification to drug discovery is more crucial than ever before.
Using CryoEM, a relatively new imaging technology, high-resolution images of various structural proteins can be taken in many different orientations. This can be reconstructed to provide an unprecedented level of insight into how virus works, including possible discoveries of previously unseen pockets for drugs to bind to.
Up to 10 billion particle images exist in a single sample. At such small scales, the imaging process requires several levels of magnification. Selecting good locations to zoom in for a reconstruction is important, because at each level, imaging defects exist which are undesirable.
Currently, manual selection of good images to magnify is non-trivial, wasting a significant amount of time and resources which could be used more advantageously. By leveraging AI processes, we can shorten the timeline to accelerate drug discovery at a revolutionary speed.
Automation of the entire image magnification and selection process can be done in part using machine learning, and in our third iteration, we focus on the Atlas view. The pipeline we created consists of using computer vision to extract and cut out grid square images, inputting them individually into a machine learning model trained to select good grid squares, then finally obtaining outputs on which regions to further magnify and which to discard.
By shortening this process of particle imaging through the intersection of cryo-EM and machine learning, a more clear understanding of the COVID-19 structure can be obtained. Ultimately, the time it takes to create new drugs can be cut down.